Yamagaki University in Japan. I am a Taiwanese, and since the pandemic, I came back to Taiwan for the first time in 4 years. So I'm very happy to be here. And okay, today I would like to talk about if we can find any associated event between FRB and GRB from Swift data. Okay, so first, as you know, fast radio burst is a new type of transient, and the typical frequency is about 100 megahertz to gigahertz. And because of the millisecond duration and the high displeasure measure, the origin of FRB should be the compact object located at a cosmological distance. And FRB could be classified to two types. One is repeating FRB, and the other is non-repeating FRB. And it is thought that magneta could be the origin of the repeating FRB. However, we still don't know very much about non-repeating FRB. And there is so many model and series try to explain these FRBs. For example, Totani 2013 suggests FRB may happen when two neutron stars merge. And on the other hand, Flake and Rizzola 2013 suggests that FRB may happen when supermassive neutron star collapse into a black hole. And this one, this model is the model I want to talk about today. And last year, there is a report FRB was detected 2.5 hours after the gravitational wave event. And however, no GRB event was detected. And since gravitational wave is related to some GRB, so if FRB associate with gravitational wave, and there must be some FRB associated with GRBs. So, and if we can find any event that late, we get one step closer to the explanation of FRBs. So here, gamma ray burst is the brightest event in our universe. The duration of gamma ray could be that's from millisecond to several hours. And also, gamma ray burst could be classified to two types. For short gamma ray burst, the origin could be the compact star, could be the measure of two compact stars. And for the long GRB, the origin could be the collapse of the supermassive star. And after that process, there will be a central engine, and a jet will launch from the central engine. And if the jet facing to our direction, we can observe a GRB. And after the initial flash of gamma ray, we can observe a longer life afterglow at longer wavelengths. And if you see the X-ray afterglow light curve, and you can see here, there is a very flat phase we call shallow decay phase. And to explain the shallow decay phase, the continuously energy supplied from the central engine is required. So spinning magneta could be the very good guess. Could be the very good guess for the central engine. And after the shallow decay phase, you can see there is a normal decay phase. And however, for some GRBs, we can see a very steep decay phase after the shallow decay phase. And the decay index is steeper than -3. And we call this phase late time steep decay phase. And to explain the late time steep decay phase, it is very difficult to turn off the spinning magneta unless it collapses to the black hole. So here is the overall view of the light gap with this late time steep decay. So first, after the measure of two compact star or the collapse of the supermassive star, we can see a GRB, and then there is the spinning magneta as the central engine, and then about 10,000 seconds after the GRB trigger, and magneta spin down and collapse to the black hole. So we can see a very steep decay phase here. So the question is, could we find any FRB event occurred at this moment? So here is what we did. First, we pick up the light curve data which have a late time steep decay phase, and the data we use is from Swift XRT catalog. And then we analyze the break time when the decay index changes suddenly. And then we compare the time with the onset of report FRBs. So I want to talk more detail about how we pick up the light curve. But before that, for some people who don't know Swift very well, let me have a very quick view of Swift Observatory. Swift has three instruments: Vast Alert Telescope, but localized GRB with a very good field of view. And then XRT X-ray telescope and U-boat UV optical telescope will do the follow-up observation of GRB. And the data we use here in this work is the data from XRT, and the energy band is 0.2 to 10 keV in the soft X-ray band. And there is about 1,500 light curve sample in XRT catalog. So to pick up the light curve we want, first we classified all the light curve to 10 type into 10 type by the shape. For example, you can see this one had a very steep decay phase after the shallow decay phase, and this one had a normal decay phase after the shallow decay phase. And for these two and these two, they look similar, but the counter rate is different. And for some of light curve, just like a thunder or just like a line. And here, our target is this three type. Okay, so after the classification, we pick up 88 light curve, have the steep decay phase after the shallow decay phase, and 39 GRB is this type, and 24 is this type, and 27 is this type. And then to know the time when the decay index changes suddenly, we fit in the light curve to the double power law function. For example, on the left is the data from Swift, and on the right is our fitting result. And after fitting, we got the break time. The break time was about 10,000 seconds after a trigger. Okay. So after removing the sample that didn't meet our requirements, we have 53 light curve after fitting. And you can see here, this light curve had a very steep decay phase after the shallow decay phase. And then we compare the time with the onset of FRBs. And the number of FRB was 536 in the time FRB catalog and the online FRB catalog. Unfortunately, we can't find any FRB event occurred at the range of the time when the decay index changes suddenly. So, what could be the problem? Maybe the data is not enough. We need more GRB and FRB samples, especially the afterglow data observed as early as 100 seconds after the GRB trigger. would be very useful. Or maybe even the FRB happen, we can see any FRB because they are absorbed by the ejector of GRB. In that case, for example, when the GRB happen and we observe from the direction here A, we can see a GRB, but we can see any FRB events. And if the GRB is the short one, and if it is close enough from us, we can also see the gravitational wave event. And on the other hand, if we observe from the direction B, maybe we can see a FRB event after the gravitational wave event. So anyway, we need more GRB, FRB, and gravitational wave sample to see if this model is true, or is correct or not. Okay, so this is summary. And thank you very much for listening.
Okay, great. So Wendy first.
Yes, thank you. I'm just a bit confused about just the generic expectation. So if you see a random event on the sky,
Yes.
the chance that CHIME is looking at that spot is about 10 to the minus 3.
Yes.
So if you have less, I don't know how many GRBs you are stacking.
GRB.
Well, you're correlating, right? You're asking if you see a GRB in Swift.
Yes.
Do you see it? How many GRBs is your sample?
GRB.
1500. There we go. 1500.
Yes.
So even if they were all in CHIME, in these white FRBs, you expect to see maybe one in CHIME, and then it's Poisson, so seeing none is, even if they're maximally correlated, if everyone is perfect, you may not see any. But we know that most of the GRBs are at redshift 1 and above, whereas we know that there are almost no CHIME FRBs at redshift 1 and above. Okay, so if you put in just the facts, you expect to see no events in CHIME, I think. I mean, if you look at that, again, I would have thought your chance of seeing them is much less than 1, just from the facts, that the sky coverage and the distance coverage. So I think you will need many more. And I don't know if you look at that, because it sounds to me like there's no way you can see them.
Okay, okay, thank you very much.
Tomo, do you have any questions? Okay.
Oh, okay, thank you very much for nice talk. So I have a similar question actually. So as Willie mentioned, actually, say the gamma burst survey is covering whole sky, right? But
Yes.
the FRB telescope, the CHIME, for example, have only narrow time window or narrow the field of view on sky. So therefore, from beginning, we have a less chance to have a coincidence. I mean, association between FRB and gamma burst. So therefore, I think increasing the number of samples is important. And then from beginning, I think you did a careful selection using the light curve or in X-ray. But this is kind of reducing the number of samples. So therefore, I just wonder if you just start from all the detected gamma bursts and then try to see if there is any association in time and location on sky, then that may have more chance to find the association actually.
Yes, maybe yes.
Thank you very much.
Thank you very much. Thank you for the comment.
Yeah, I have related comments. I remember this year one paper about possible association with GRB or
really?
FRB was published. So this report also by Fermi GBM, I guess. Okay, but so maybe it's better to look at it. Maybe you can also find this in maybe Swift. I don't know. Yeah,
Thank you very much.
Just a comment. Thank you so much.
Thank you so much.
Great. So thank you for your talk.
Thank you very much.
So let's move on.